Hello, folks. Happy Thursday, and welcome to a radical lesson. Get it? Radical? Excellent. All right. The sub should have gave you a note sheet front and back. Yesterday we worked with the square root function, and today we're going to take a little look at the parent function called the cube root function. So, without delay, let's begin. So if I look at the cube root function, okay, remember the cube root function can also be written as, one moment, x to the 1/3. Okay, we can work with the cube root. Now, again, when we're graphing, we want to pick some key points. 0, 1, -1, 8, and -8. Okay. So here we go. Cube root of 0, 0. Cube root of 1, a little rusty. Cube root of 1 is 1. Cube root of -1, -1. Cube root of 8, 2. Cube root of -8, -2. So, going in 0, 0, 1, 1, 8, 2. -1, -1, -8, -2. And if I connect the appropriate curve, that is my cube root function. Easy as that. Now, the key is that is the parent cube root function. Okay? Now, we're going to graph. I'm going to put a new slide in that you don't have, but I want us to talk about, and just a quick reminder of our rules for transforming functions. They still hold true for the cube root function. All right, one change. Take out the A, and actually that's going to be an H. So all the same rules apply as we had yesterday for the square root function, and you can see 8.7 day 1 notes for that information. Okay, so let's move on and let's do some graphing. So notice, describe the transformation and graph. So as I look at this graph, I have right here a 2. That 2 is A. So that's a vertical stretch. By 2. The other 2 is the H. So we have a horizontal translation to the right 2. All right, so what that means is I have two options. I can make a table of values to graph, which is excellent. I'm going to graph the original function. My key points, 0, 0, 1, 1, -1, -1, 8, 2, -8, -2. Again, if I'm going too fast, which I might, because it's all functions and fun, feel free to pause the movie at any time. All right, so we can put these points on the graph. I'm just going to make dots right now because we're going to be moving them. Okay, I'm going to transform this function right there. That's the original. And my rule of thumb is order of operations. So I do vertical stretches first, then horizontal translation to the right. Okay, so every y value here is going to get multiplied by 2. So 0 times 2 is 0. 1 times 2 is 2. -2, 4. negative 4. Okay? So I move every point. 0, 0 is going to stay there. But the 1, 2, the 1, 1 is going to be 1, 2. And I'm gonna keep going there. But next, I take care of the horizontal translation to the right. So I need to take every x value and add 2. 2, 3, 2 and negative 1 is 1, 10, negative 6. Right? So I have my points to graph. I'm going to go in a different color, blue. And we're going to go, now I'm going to graph these points for my new function. So 2, 0. Okay, so that's a vertical stretch of 2 moved over 2. I'm going to go 3, 2. So this first point was stretched up to 2, and it was moved over 2. So 3, 2. 1, negative 2. 1, negative 2. Sorry about that. 10, 4. Right there. And negative 6, negative 4. And I connect. And there's my graph. Okay, key points. And if I compare that to the original graph, okay, if I want, I can maybe dash that one in. And there you go. It's stretched up and over to the right too. All these points right here are multiplied by 2 and over 2. Okay, multiplied by 2 over 2 is another way to graph. Okay, there we go. So here we multiplied the original function by 2. Okay, very good. Very good. So we're continuing on. Thank you. Good work. Okay, now some inequalities. Okay, so now we're going to have some shading. Remember, whenever you graph an inequality, we're looking for a shaded area. So the two-step process for these types of problems is to graph the function, which is square root of x plus 4, and then shade the area. Okay, and if you want, you can use a test point to check and see which area to shade. So if I'm graphing f of x equals square root of x plus 4, that is a translation 4 to the left. Okay, so I'm going to take the original points of x and square root of x. So 0, 0, 1, 1, 4, 2, 9, 3. And I'm going to adjust only the x values by taking x and subtracting 4. Negative 4, negative 3, 0, 5. Or if I want, I could actually take the original points right there, and I can move them all 4 to the left. Right, we'll take a different color. Negative 4, 0. Negative 3, 1. 0, 2. 5, 3. Every point is 4 to the left. Now I have to shade accordingly. Okay, and for that, we take a look at the symbol. When I see that symbol, I need a dashed line. Now, my next step is to shade. And since this is greater than, most likely I'm going to shade above the graph. Now I have to be careful. Because according to my domain, x is such that x has to be greater than or equal to -4. Otherwise, I would get negative numbers under the radical. So I have to stop my shading at -4. So when I go to shade in, I'm shading, and I got to make sure I stop at -4. There we go. Excellent. Okay. Moving on. Now we have a cube root. Let's see, what do we got left? All right. We got a cube root function. So again, I'm going to graph the original. So I'm going to graph f of x equals the cube root of x minus 3. Greater than or equal to. So that's going to be a solid line. This is a translation to the right 3. So I'm going to take the original cube root function right there, 0, 0, 1, 1, -1, -1, 8, 2, -8, -2, and I'm going to take every x value, because it's going to the right, and I'm going to add 3. 3, 4, 2, 11, -5. Now I have my new points. I'm going to graph 3, 0, 4, 1, 2, -1, 11, 2, and -5, -2. And there we have it. Solid line graph. Okay, it's greater than, so I'm going to shade above, and I can keep this shading going because I can have numbers, and this keeps right on going in both directions. There you go. Excellent. And the last one today, another cube root. This time we have a reflection over the x-axis and a translation up 2. Okay. And then I'm going to shade solid line. So for this one, the cube root, I'm going to take the original and I'm going to perform the reflection and then move it up 2. So I'm going to do this one without a table. So each one of these points is going to be reflected over the x-axis. +2, -2. This one's going to come down here. -1, +1, +2. And then I'm going to move every point 2 up. Up 2, up 2, up 2, up 1, 2, up 2. So my graph is here, down, out that way, and shade in a point. If I put in 8, cube root of 8 is 2, negative 2, 0. 0 is less than 8. 0 is less than 2. That's true. Greater than, shade above. Excellent. So this will be the assignment on Monday. So you have no assignment this evening, but make sure your 8-6 A and B and your 8-7A are completed. And that's it for a wonderful Thursday. Again, have fun. Function starts with fun, and I hope you had a radical lesson. See ya.